orbital theory. See, when we are talking about the chemical bonding by the valence bond theory, we only talked about the overlap of the valence shell. Okay, this is nucleus A and this is nucleus. Here you have one electron and here you have one electron. So, overlap of the valence shell has given rise to the formation of a chemical bond. The two atoms from very far approach each other, and when they approach each other, they develop two types of interactions, attractions and repulsions. When the attractions overcome the repulsions, then gradually the valence shells start overlapping with each other. They approach the opposite nucleus and they stop in a place where the repulsion then becomes maximum, and that internuclear distance is called the is called the bond length. In molecular orbital theory, these are the valence shell. Within the valence shell, these are the inner shells. In molecular orbital theory, what we say that no, all the orbitals in an atom, they come and overlap with each other, leading to the formation of all the orbitals inside they overlap with each other. Okay? So, in this case, each and every orbital that you have inside the atom, they overlap with each other. This is called the molecular orbital theory. Okay? So that is the one that we are going to discuss. You have to draw it. This is valence bond theory, and this is the molecular orbital theory. No, it's a neater formula. Molecular orbital theory was developed by Hund and Mulliken. The basic idea of molecular orbital theory is that atomic orbitals of individual atoms orbitals. atomic orbitals of individual atoms combine to form molecular orbitals. Which are associated with several nuclei. These molecular orbitals are filled in the same way as the atomic orbitals. Atomic orbitals in an atom. Means in the atom we fill up from lower energy to higher energy. Molecular orbitals also electrons are filled up from lower energy to the higher energy. What is the meaning of which are associated with several nuclei? Okay, I'll show you. Say you have taken fluorine. I'm not drawing the electrons. See, 2 fluorine. Fluorine has 1s2, 2s2, 2p6. So this is the fluorine nucleus. This is the first shell, and this is the second shell. See here. So these two orbitals they mix. So what you are going to have? See here. This is the first shell will overlap, and the second shell will overlap. So in this one, you have 2 nuclei, and both the orbitals are moving around the both of the 2 nuclei of fluorine. So you have gone for say for carbon. So carbon also has 2 shells. Okay. Now you have hydrogen. So you have hydrogen now. So I'll write here now 4 hydrogen. So this is hydrogen as 1 shell. So what you are going to get here? See, this is the carbon. This is the inner shell does not combine, and these are the 4 hydrogen nuclei. These are the hydrogen nucleus. See here. This is like this. So how many nuclei it has? It has 5 nuclei. Draw. These are not difficult, huh? Unnecessarily don't get scared. Good. The moment you finish, you tell me. Okay. Now, salient features of molecular orbital theory. Okay, now what? Electrons in a molecule are present in the various molecular orbitals as the electrons of atoms are present in the various atomic orbitals. That is, where in an atom, electrons are present in atomic orbitals when they form molecule. So all the electrons will be present in their molecular orbitals. Second. The atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. I told you that symmetry always has to be mentioned. Molecular orbitals. Third. While an electron is in an atomic orbital is influenced by one nucleus, because in an atom you nucleus have only one, and all the electrons are influenced by that nucleus only. In a molecule, in a molecular orbital, it is influenced by two or more nuclei. Depending upon the number of atoms in the molecule. Thus, an atomic orbital is monocentric. What is monocentric? One nucleus and all the orbitals are around it. So it's called monocentric. While a molecular orbital is polycentric. Because you have more than one nucleus. See, I am trying to write it in brief. So maybe within 1 month, I'll be able to send you PDF file for the chapters we have already taught. Generally, I don't give notes, only in the class.
Yes, sir.
Yes. The atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. See, when the orbital is going to overlap with each other, the energies should be same. It's just like that. How do you make friendship? Okay, we make friends with those people with whom our attitude, our way of living, our way of thinking matches. Is it not? So obviously, 1s is not going to combine with 3d of another one because the energies are different. So if these are the atomic orbitals, see dear, these are the atomic orbitals. So these two are having same energy, so it will combine. Then it will combine, and it will combine. This one will not combine with this. Okay. So their energies should match, and moreover, symmetry should match. That they have shown you. That positive lobe overlaps positive lobe, negative lobe overlaps negative lobe. Negative will not positive will overlap with the positive. Understood now?
Yes, sir. Thank you, sir.
Okay. Can I wrap first and second?
Yes, sir.
Yes, sir.
Molecular orbit is very interesting. After that I'll just explain you through mathematical law. Okay. The number of molecular orbitals formed is equal to the number of combining atoms. I'll explain everything. You have to give me some time for this one. Combining atomic orbitals. when two atomic orbitals combine. Two molecular orbitals are two molecular orbitals are formed. One is known as bonding molecular orbital, while the other is called anti-bonding molecular orbital. So what is the meaning of this one? The meaning is this. See, suppose these are the two persons. Okay? They meet. After they meet, there can be two types of interactions. That is, either you may like his presence or you may dislike his presence. It is there in human society. In that case, what will happen? If both of them appreciate their presence, then it leads to a friendship. That is called bonding molecular orbital. And if they cannot stand each other, there cannot be any relationship or friendship. All right? Then they will start disliking each other, there will be repulsion. So here will be attraction and here will be repulsion. So in that case, we call this to be anti-bonding molecular orbital. Clear? So anyway, after when you write, don't give this example. See, when you like someone, okay, so in that case, you will find that companionship gives you happiness. All right. So in that case, the energy is always lowered. We can sit with friends for a long time or relatives long time together. Okay. But when you dislike someone, that repulsion is being created. For that, you have to spend more energy. All right. So in that case, why should you hate anyone when you have to spend your more energy? Right. The bonding molecular orbital has lower energy. See here, I told you, energy is less. Lower energy and hence greater stability. Hence, greater stability. Then the corresponding corresponding antibonding molecular see. Please stop writing. See, in atomic structure, what did I say? The psi is the wave function of an electron or amplitude of the electron wave. It is an imaginary function. And I told you, if you square it, psi square is nothing but the probability of finding electron in a certain place. And that we call it orbital. Similarly, when two atomic orbitals combine, okay, when two atomic orbitals combine, say it is psi A and don't write, and psi B. Okay, these are the two atomic orbitals, electron waves are combining with each other. So what will be their molecular orbital? We have to square it. See, dear, if this is atomic orbital, then this is a molecular orbital. Okay, so that is the one that I'm going to write now. Can I rub this one, upper one?
Yes, sir.
Just as the bonding molecular orbital electron probability distribution, that is atomic orbital. Around the nucleus, in an atom is given by an atomic orbital I'll write here, say psi A square or psi B square. The electron probability distribution around a group of nuclei. In a molecule is given by molecular orbitals. Say psi A plus psi B square. This is bonding orbital, dear. Or psi A minus psi B square. This anti-bonding. You can write below. Bonding, anti-bonding. See, so much I'm writing, so don't get scared. Ultimately, you'll find within few lines the whole summary will be there. And I'll start drawing the orbitals. It's just like that you bought a piece of cloth from the market to make your dress. See, you go and buy, then you go to tailor, then the person takes your measurement, cuts the cloth, stitch it, everything. Then it takes a long time. But how much time it requires to wear that cloth? Seven. The molecular orbitals like atomic orbitals are filled in accordance, same like that we have done now, our rule and all this thing, in accordance with the above principle, means lower energy to higher energy. Pauli's exclusion principle. According to Pauli's, you cannot put more than 2 electrons in an orbit, not an orbit, orbital. Exclusion principle and Horn's rule. See, we write PXY, PY, PX1, PY1, PZ1, D111 like this, having the same energy. Here also it is same. Horn's rule.
Unless you open the box and you want to not big. That's straight up.
Okay, after finishing, you tell me. I have taken so much time in this chemical bonding, though we did not waste. So,
Done, sir.
okay. Now, we come to another principle. It's called linear combination of atomic orbitals. Now the atomic orbitals will come and combine with each other. So these are all our all the things that we have written is the understanding of molecular orbital theory point-wise in a nutshell. Now we will go for linear combination of atomic orbitals. That is, we are going to form molecular orbitals are formed by linear combination of atomic orbitals. Linear combination of atomic, in short form we call it LCA. Molecular orbitals of molecules are obtained by the linear combination of atomic orbitals of the bonded atoms. This is then I'm going to show you now. How does an atomic orbital looks like? The electron waves that describe the atomic orbitals have positive and negative phase. Have positive and negative. See here. Say I'm writing here. Psi. See, this is the orbital. It is like this. So this is the positive phase, the negative phase, positive phase, negative phase, positive. Now, psi B. This is the one. When the waves are combined, they may interact interact constructively or destructively. What is the meaning of this? See, when we are being invited to do some work, if you like that job, you will put interest and try to make it better. And if you don't like, you will somehow try to spoil that one. Same thing happens in atomic orbitals. So in that case, it can be constructively and destructively. I'll show you. When they are added, they combine constructively. To produce wave with psi A plus psi B amplitude. So I will not draw this wave now really big. See here, psi A. So it is like this. Psi B. See, they are in the same phase. When they're in the same phase, they will be added. So when you add them, what will happen? The amplitude is going to increase. So in this case, I write down here constructive interference. Okay, that is this psi A plus psi. How it will look like? See here. Here the height and the depth is going to increase. So it will be S. What do you mean by this? Say, suppose in the ground, you have made a hole. So what will happen to the soil? The soil will be here. Now, if you make it deeper, say initially it was like this, the soil was this much. When you have gone dig it further, then the soil is will be deep will be more and depth will be more. So this is the same thing happen. This is called constructive interference. Conversely, If they subtracted they combine destructively to produce wave with psi A minus psi B amplitude. Okay, see here, psi, it is like this, psi B. See, they are not having the same phase now. So it is like this. See, plus, minus, they will cancel each other. This. I did what I'm going to get. So, this is called destructive interference. Okay, this is psi A minus psi B. See, is it not one will be subtracted from the other? So what will happen? You see now, the height will decrease. So it will be plus, minus, plus, minus, plus. So in that case, the bonding will not take place. Huh? So here I am doing the only the amplitude, mind it, wave function, not the molecular orbital or atomic. So not the molecular orbital, because square of the amplitude is the atomic orbital. So square of the constructive interference will be the molecular orbital, and square of the destructive interferences will give you the molecular orbital, antibonding molecular orbital. So let me tell you what is the meaning of constructive interference. What is the meaning of interference? This is the only thing which you do not like in your life. Interference means someone is present in your activity. Is it not? See, suppose in the evening you are watching TV. Okay, you are watching TV, or you are busy with your mobile. So by evening time, generally we have made a rule: the morning and evening is for study. So at this moment, suddenly you have found that it is your mother. Okay, with this type of eyes. Okay. So, do you like her presence when you are watching TV and you are playing with your mobile? Hello?
So if she disturbs.
Obviously, others she has come to give you a hug or what? When you are watching TV in your study time, she will tell that I'm so proud of my daughter. So, in that case, you do not want her presence in that moment in the room. That is called destructive interference. All right? But suppose you are going out somewhere to meet your friend or anywhere. That moment you meet your mother and she immediately hands over 200 rupees note in your hand. So do you say, no, I don't want? Huh? Hello?
No, sir.
So this is called constructive interference. You wanted our presence at that moment. Understood? Ah. So constructive interference lead to the it leads for some useful purposes to build something, and destructive interference is always being done to demolish or deactivate the process. All right. So now we'll write the probable electron density. There, what is that? For atom, it is atomic orbital, and for molecule, it is a molecular orbital. Then we'll write here molecular orbital. Molecular orbital is given by the square of the amplitudes. Okay. So now we'll write bonding molecular orbital. Okay. Now what is this? This is done by the constructive interference. This is the one. Psi A plus psi B square. If I expand it, you know it. According to algebra, what should I get here? Psi A square, psi B square plus 2 psi A and psi B. And anti bonding molecular orbital. Is equal to what? Is psi A minus psi B is equal to psi A square plus psi B square to psi A and psi B.
Sir, done.
Now what is the meaning of this? See here. So here I'm going to write. Therefore, see here. These are the individual atomic orbitals. So what did you find here? In this case, we find psi A plus psi B where is greater than if I add the electron density of the atom to atomic orbitals. So is it not this? Because this factor is there. That is, the electron density between the two nuclei now increases more than that by an amount of this. These are the individual atomic orbitals which you have mixed. In the molecular orbital, when they form, we find now the electron density in between the two nuclei has increased by a factor of 2 psi A plus psi B. And in this case, we find that this. In this case, what did you find? That when I mix both of them, some amount of electron has disappeared from that place. Then it leads to repulsion. So I'm going to explain it to you. See here. Two atoms are approaching to form one. Okay. So when they form the bond, in that case, we know the electrons always lie in between the two nucleus. So in that case, what will happen? This type of overlap takes place. And these two nuclei will come to a maximum distance where the repulsion between them is minimum. So when it is having positive charge nucleus, so how to decrease their repulsion? To decrease their repulsion, if you put some more electron inside, because the negative electron is going to reduce the repulsion of the two positive charges. So if more amount of electrons are being put here, in that case, repulsion is less. So they will come closer. You will find if suppose some sort of misunderstanding or quarrel breaks out between two friends. All right. If they're alone within themselves, then the quarrel will increase. Each one of them will go start abusing and finding fault with others. So this relationship is not going to last. So what we do? You'll find immediately some of other friends will come in between them and try to make them understand whatever they're doing is not good. And gradually, in that case, they may feel sorry and the relationship is going to last. So this is the extra amount of electron which is present in between two nucleus, reduces the repulsion and make the bonding strong. That one we call it bonding molecular orbital. And in this case, see here, some amount of electron has already disappeared. So when they start forming the bond, before they overlap, the repulsion starts. See, before they overlap, the repulsion starts. In that case, the bonding does not form because of this disappearance of the electron cloud in between two nuclei. Repulsion energy is always higher. Okay, see here now. So in that case, what I can do? Say we have electron here and we have electron here. All right, let me write it like this. In this case, you'll find this is the bonding molecular This is the molecular orbital bond. Repulsion is less, energy is lower. And this is the one you'll find. In that case, this is the anti-bonding. So like that. Molecular orbital anti-bonding. So this is the bonding and this is the anti-bonding molecular orbital. Okay, now we'll go for conditions. What are the conditions has to be satisfied before going for bonding? This is important for your exam. Conditions for combination of atomic orbitals to form molecular orbitals. Three conditions are there. So this one you take care for your exam. The combining atomic orbitals must have same or nearly same energy. So in one word, what we can say, that is comparable energy. Then second, the combining atomic orbitals must have proper orientation that I told you in orbital overlap. Means positive will overlap positive and negative will overlap negative. Proper orientation, that is same symmetry, same symmetry about the nuclear axis. Third, the combining atomic orbitals or atomic orbitals must overlap to the maximum extent. Obviously, if our orbital is minimum, then it will open up maximum extent. These three is important for your exam.
So done.
Okay. So let us see now the type of overlap. So right now, types of molecular orbitals. Just as the atomic orbitals are designated as S, P, D, or F. The molecular orbitals of diatomic molecules. In your syllabus on diatomic, diatomic molecules are named as sigma and pi. Okay, then we will write now here. Sigma molecular orbitals are cylindrically. Cylindrically means just like this, huh? Don't get, this is like this. Around nuclear axis. So I'll draw it. Now see. Yeah. This is the overlap of two S orbitals, huh? So S, they are S. So in that case, what is going to happen? They may go for bonding or they may not go for bonding. It is said that as many orbitals you take, you are going to have that many numbers of molecular orbitals. Two orbitals are there, there will be two molecular orbitals. One will be bonding, another will be anti-bonding. All right. So now, see here, bonding molecular orbitals have. This is when I draw like this. This is a valence bond theory. So, in molecular orbital, how it will look like? See here. These are the nucleus. See. This is the nucleus. This is so. This is the one. It will be sigma s. Okay. And if the repulsion takes place, what will happen? If the repulsion takes place, in that case, what you will have? They are not going to combine. So this is the internuclear axis. See, they are cylindrically arranged. That is, if I pass, say, if it is a see-through, and if I can pass one wire, then this is the electron cloud. And say these are like this. When they combine, it will be like this. And when they repel, so it will be like this. That is, now, in that case, what you find? This is the plane where no electron is present. This is the zone of hatred. Okay? Nothing is there. No electron is there. So there we call it, this is called nodal plane. The nodal plane. So here, what do you find here? How we are going to express? I will write here sigma star s. So what I will write now here? That sigma star s has one nodal plane. Ligo, patapot. I'll take 10 more minutes.
So done.
Very good, very good. Acha, what about Mehak? Mehak to khabar nahi rahi. Hello.
Sir, I don't know.
Well, she is not from your locality.
Yeah.
We'll go for. See, we are saying that it should have the same of the comparable energy. So S has combined with S. All right. Now we'll go for P. See here. When you go for P, they have to maintain the symmetry. Energy is the same, symmetry is same. All right. So when it is like this, it is P, P. So I'll draw it like this here, like this here. Okay. See, it almost looks like a toffee. Here, this is plus, this is plus. So I call it this sigma 2p. Here I'll write this pz. We always come to consider pz orbitals only form sigma 2pz. Okay. So this is the internuclear axis that is passes through it. Now, if the symmetry is not maintained, see here. This symmetry is not maintained. In this case, what is going to happen? They are not going to form. So this. So see, this is the which is sigma star 2pz. So what we can say? That sigma star 2pz has one nodal and this has no nodal.
Sir, done.
আরে খালি তুই ডান করলে হইতো না রে, বাকিরা কি ডান হয়েছে নাকি? ক্লাস আছে নাকি আজকে স্কুলের?
Sir, I have.
আচ্ছা, now we'll go for pi orbitals. We know pi orbitals are formed by, see these are all head-on overlap, formed by lateral overlap of px and py orbitals. So see here. See, they are maintaining the same symmetry. So it is px or py. Px or py. That is px and px will combine, or py and py. But px will not combine with py. So now what you are going to get? See here. This and this. Please do it little nicely, huh? See here. So this is the pi px or pi py. See there, this is the nodal plane. So this is the nodal plane. That is, see, sigma bonding did not have any nodal plane. Sigma star had one nodal plane. But in case of pi bonding has one nodal plane. Now I'll go for now pi anti-bonding. See here. Plus, minus. See, symmetry is not maintained. So they are not going to form. So what we are going to form? Repulsion is there. As the repulsion is there, electron cloud is being moved away from the nucleus. See here. This is plus, minus. Minus, plus. There, see, it has two nodal planes. So I'll call it pi star px or pi star py. Okay. It has two nodal plane. Remember for your entrance exam, this one. This is, I'll write down here, nodal plane. So this is one nodal plane and this is the other nodal plane. Okay. I think I'll take 2 more days.